where I tell you that if in an isosceles triangle, if two sides are equal, then these two angles would also be equal. Remember this, both of you?
Yes, sir.
Adrian, did you get it?
Yes, sir.
So, bacha, I can write angle BAD plus angle, instead of this, I'm going to write angle CBE is equal to 180. Okay. Now, bache, we also know that angle ABC, this one, plus angle EBC, this is also 180. Angle ABC plus, sorry, plus angle EBC is equal to 180 degree because of linear pair. Because of linear pair. Now, guys, if you see carefully, na, what you notice is from here I'll find angle BAD is equal to 180 minus angle CBE, and from here angle ABC is equal to 180 minus angle CB. This is I can write a CB also angle CB. So just since both are equal to 180 minus angle CBE, I can write angle BAD is equal to angle ABC, and this is what we needed to prove, that angle A is equal to angle B. So first part proved. Did you get this? I know this might be a bit difficult in understanding, but I hope you got this part, both of you.
Yes, sir.
Yes, sir.
Okay. Oh, it's already 31. Guys, I have another class. We'll continue this in the next class. Okay, I'll explain this properly in the next class.
Yes,
Okay.
sir. Thank you, sir.
I have another.
Yeah.
Oh, okay. Thank you, guys.
Thank you, sir.
Bye.
Okay, so hello everyone. Ali and Rimda, how are you?
Hello, ma'am.
How are you, Rimda?
I'm good, ma'am. How are you?
Yeah, I'm good. Okay, so did you revise the topic? And you guys are not submitting your homework. Why? I told you to submit your homework before the next class so that we can discuss the doubts. Okay, so please submit your homework as soon as possible. Okay, so we were discussing the chemical properties of ethers. So in which we have done with symmetrical ethers as well as the unsymmetrical ethers, right? So how you will break the unsymmetrical ether? So first you will choose the tertiary carbon. Okay, you will check whether there is a tertiary alpha carbon or not. If there is a tertiary alpha carbon, then attach the halogen atom to that alpha carbon and attach the hydrogen from the halogen bromide. See, this is your hydrogen bromide. So you have to attach the bromine halogen to the tertiary carbon. If tertiary alpha carbon is present in your compound, in your unsymmetrical ether. And on the other hand, you will attach this remaining hydrogen to the fragment, to the remaining fragment. So you will get your tertiary a haloalkene plus your alcohol. The product will be your alcohol plus your tertiary haloalkene. Now let's see the mechanism. What is the mechanism for this reaction? Okay, so we have Hi. Suppose we have Hi, okay, halogen, your hydrogen iodide. So this hydrogen iodide, it will dissociate to form H plus your I minus ion, right? H plus and I minus ion. Now, when you have this one, so we were doing the mechanism for this reaction. Okay, whether there is a, this is oxygen, this is your ethyl group, and here there is a tertiary structure. Right. This is your tertiary structure. Okay, write like this. Okay. Now let's see the mechanism. So when you take the halogen acid, okay, your halogen acids, your hydrogen Hi. Here we are just taking the Hi. So hydrogen iodide, it will dissociate to form H plus and I minus, right? I minus ion. Now this is your ether. So this ether has oxygen and oxygen has a lone pair. Oxygen has a lone pair. So this H plus, this proton, H plus, so this oxygen of the ether, it will abstract this proton. First step again, the protonation. Okay, the protonation of ether. The protonation of ether. So this oxygen, the lone pair of oxygen, it abstracts this H plus ion and it will become oxygen. Here you will write H and this whole group, tertiary group, and here on this oxygen there will be a plus charge. Okay, now see the next step. So this OH plus, right? So this oxygen has three bonds now, right? So it will acquire positive charge, positive charge. So from this bond will break, right? So this bond will shift over here and this bond will break. So you will get a alcohol. Okay, CH3, CH2, and this OH. CH3, CH2, and OH. Okay, now what about this group? When this group cleave from here, so you will get 1, 2, 3, this tertiary structure. This is structure, and this carbon to this carbon, there will be a positive charge. So it will form a carbocation. What you say? See, let me repeat this. Okay, this is your first step, protonation of this oxygen. Okay, this ether get protonated and you will get this compound. Now, this bond is quite unstable, right? And this oxygen has a positive charge. So this bond will shift over here. So this bond will break. From here, this bond will break. So you will get 1, 2, 3, 4, right? This 4 carbon. Okay, just this is structure, tertiary carbocation, and on this carbon there will be a positive charge, so it will form a carbocation. Next step will be when it forms a carbocation. So we have a iodine minus, I minus charge over here, right? So this H plus has been consumed in the first second step, right? Protonation part, but this I minus is already here. So this I minus, I negative charge will attack this carbocation. This attack this carbocation, and you will get this one. 1, 2, 3, and here iodine group, right? This thing you will get. So you can see over here what you get. This tertiary group में क्या attach हो गया? This tertiary group will this iodine will get attached to the tertiary part. Okay, the tertiary structure, tertiary alpha carbon, and you will get a primary alcohol. So these are the two first product, alcohol, plus here what is this? This is your tertiary haloalkene. Tertiary alcohol. Iodine is attached to this carbon. This is the alpha carbon, and this alpha carbon is tertiary, right? So that's why what you are supposed to do in the unsymmetrical ethers. So first you have to check whether there is any tertiary alpha carbon or not. If there is any tertiary alpha carbon, just attach the halogen part of the halogen acid, halogen part to that carbon, and the remaining fragment will form the alcohol. Okay, so that is the proper mechanism for the unsymmetrical ethers. Okay, this this H plus, it will dissociate from H plus and I minus ion. Second step is the protonation, right? Protonation of this ether. Third step, you will get the formation of carbocation and the attack of your I minus ion, right? And it will give you this tertiary structure. Is the mechanism clear, Ali and Rimda?
Ma'am.
Okay. Now the question is, it is not compulsory always that in your product there will be a tertiary alpha carbon. Question is, if tertiary alpha carbon is not present in this structure, then what we are supposed to do? Okay, so see. So we have, if only primary and secondary alpha carbon is present, means tertiary is absent. So what we are supposed to do? Then the alkyl group with which is less hindered. Less hindered कौन सा होगा? Primary one. The alkyl group which is less hindered will get the halogen, and the rest of the fragment will form the alcohol. Okay, so again I'm repeating. So there are two cases in unsymmetrical ethers. First case is if tertiary alpha carbon is present. You have to check whether the tertiary first step is always check whether there is a tertiary alpha carbon or not. If there is a tertiary alpha carbon, then attach the halogen part, okay, to the tertiary alpha carbon. So you will get a tertiary haloalkane. Okay, plus the remaining group, the remaining fragment will form the alcohol. Means you are supposed to attach the H, okay, to the oxygen. When you attach the hydrogen to the oxygen, the ether, this ether oxygen, so you will get the alcohol. But if tertiary structure is not present, tertiary alpha carbon is not present, so we have to check whether it's a primary or secondary, right? So primary is less hindered, right? Primary is less hindered, so attach the halogen to the primary structure, to the primary alpha carbon, not to the secondary alpha carbon. Okay, so if tertiary is not present, then primary and secondary alpha carbon is present only. Then alkyl group which is less hindered, and less hindered is always primary. Okay, primary alpha carbon. So attach the halogen to the primary alpha carbon, and the rest of the fragment will form the alcohol. Is this point clear? Yes or no?
Yes, ma'am.
Remda, is it clear?
Yes, ma'am.
Okay, then let's do this question. So this is your ether, right? So you can see this is an unsymmetrical type of ether. So first step, just check whether tertiary alpha carbon is present or not. So there are two groups. This is the oxygen linkage. This is alpha 1, suppose, and this is your alpha 2. Okay, now check this alpha 1 is primary structure. This is your primary carbon, right? And this alpha 2 is, what is this? This is the secondary. This is your primary and this is your secondary. Means there is no tertiary alpha carbon. So if there is no tertiary alpha carbon, so we have to attach this iodine, the halogen part, okay, of the halogen acid to the less hindered. And which one is less hindered? Primary structure, right? So this is structure. This primary alpha carbon को आप attach कर देना this iodine. So you will break this bond. You are supposed to break this bond. Okay, so you will get 1, 2, 1, 2, and iodine. 1, 2 carbon and then iodine attached. And the remaining fragment, this whole thing will, so hydrogen will get attached to this oxygen and it will form a alcohol. Okay, so you will get a secondary alcohol plus your primary halogen, your haloalkene. Okay, so in this type of question, when the primary and secondary structure is secondary alpha carbon is present, so you will get a secondary alcohol and your primary haloalkene. Okay, then do the second and third. Ali and Rinda, quickly do this. And yeah, if both are primary structure, then you have to choose the less hindered, and less hindered means the less number of carbon. The less number of carbon will form the haloalkene, okay, and the remaining fragment will form the alcohol. Okay, just quickly do the question number second and third. Yes, Ali, tell me the second answer.
CH3 CH2OH plus CH3Br.
Very good. Plus CH3. Yeah. Okay, so you will break this bond. So the less number of carbon, which is less hindered, will form the haloalkane, and the remaining fragment will form the alcohol. Yes, Rimda, next. Third answer.
CH3, CH2I, and OH.
CH3, CH2, iodine over here. Okay, and the remaining fragment. So this bond will break and this fragment will form the alcohol. So it will form propanol, 1, 2, 3, and OH. Propanol plus your CH3, CH2I. Okay. Next is alkoxybenzene. Okay. So alkoxybenzene always forms, just remember, it will always forms the phenol and haloalkene, right? Because you don't have any options. Which bond you will break? You don't have any options because you know very well this oxygen, the lone pair of this oxygen is involved in the resonance with the benzene ring. So you can't break this bond. Okay, because here there is a partial double bond character, So it is very difficult to break this bond. This carbon, the benzene carbon and this oxygen bond. So you don't have any option. Okay, so basically आपको क्या करना है? This bond you have to break, and it will form, the hydrogen will get attached to the oxygen, right? And this R group, okay, R group will attach this. R group के साथ क्या attach होगा? This iodine one, right? This iodine part. So alkoxybenzene always forms a phenol. Okay, you have to prepare the phenol and the haloalkene. So what you're supposed to do, just break this bond, this OR bond, right? Attach the hydrogen to the negative part, which is oxygen. So OH, it will form phenol, and the remaining one R and I. It's very simple. Okay, do this example. Yes, so it's very easy. So you have to break this bond, right? This oxygen and this carbon bond. So phenol, the hydrogen will get attached to this oxygen. So it will form phenol plus this one, 1, 2, 3. Yeah, so here to the second carbon, you have to attach the bromine. Which carbon? Second carbon. So this is the first CH3, CH2, and the CH. So you have to write thing here, bromine. So that is the product. Okay, next is your benzyl alkyl ether. Benzyl alkyl ether. Now here, see this. So you know very well this benzylic carbon is very reactive. Okay, this is benzene ring, and the carbon which is directly attached to the benzene ring, this carbon is known as benzylic carbon. This is your benzylic carbon, and this benzylic carbon is very much reactive. Okay, so this bond, again, you don't have any options. What you're supposed to do, basically we have to break carbon and oxygen bond, right? So we have to cleave the carbon and oxygen bond. Now this is you have two options. You can break this bond or this bond, right? But this C carbon, this benzylic carbon is very reactive. So due to that, this bond will break. This bond will break, right? And what you are supposed to attach, so this oxygen is negative, right? It is more electronegative than this carbon. So it will acquire partial negative charge, and this carbon will acquire partial positive charge, right? And between this hydrogen and iodine, so it will dissociate to from H plus and I minus, right? So this H plus will get attached to the negative part, which is oxygen, and this negative part of the halogen acid will get attached to the positive part, which is carbon. So you will get your this benzylic group, right? Benzylic carbon, and the iodine will get attached to the carbon, right? Plus RO and this hydrogen, ROH. Okay, so this is your product. This is your product. Is this clear? How you will cleave the benzyl alkyl ether? Yes or no?
Yes, ma'am.
Yeah, so when the benzyl alkyl, this type of compound is given, so you are supposed to break this bond, this carbon, benzylic carbon, and this oxygen bond, right? And the product will be this. Okay, ROH, alcohol, plus your compound, this iodine. Okay, do this question. Do these examples quickly. And all these examples, they your benzyl alkyl ether, right? Your alkoxybenzene. So this unsymmetrical ethers that we are doing, the cleavage of CO bond. So this reaction, the reaction of ethers with HX, your halogen acid, is a type of SN1 reaction. Okay, unimolecular nucleophilic substitution reaction. And unimolecular nucleophilic substitution reaction occurs in two steps. Okay, which involves in the formation of carbocations. So that's why the carbocations is being formed over here. You can see the formation of carbocation in this step. Okay, you can see the formation of carbocation. So this is a two-step mechanism. Okay, SN1 reaction, unimolecular, right? So it occurs via two steps. First step, the living group will leave. Okay, and the second step, basically the living group will leave and the formation of your carbocation. And after the formation of carbocation, the nucleophile, nucleophile will attack the carbocation and it will form the product, right? So you can see over here mechanism में आप देख सकते हो. First यहाँ पे protonation हुआ, right? After that there will be a formation of carbocation, which is this tertiary carbocation, and tertiary carbocation are very reactive. Okay, very reactive and very stable. So this iodine minus, which is a nucleophile over here. What is I minus? I minus is a nucleophile which is having a negative charge. So it will attack this carbocation and it will form this product, right? So these reactions follow the SN1 mechanism. Okay, now I'll quickly do this question. Example 1 and 2. You can also write this structure like phenyl, both the sides, both the terminal, phenyl ring is attached. So you can write this. This is CH2, oxygen, and again there is a done. Yes, solve the question. Why you guys don't respond? At least respond to it. Hello.
Yes, ma'am.
Yes, Rimta, solve the question. Okay,
Ma'am,
tell me.
first one is C6H5OH plus ICH3 twice.
Okay, so basically you will break this bond, right? This bond. Because this is CH3, this is benzylic. Sorry. Just a sec. So what you're supposed to do, just this benzylic carbon, this is a CH2, right? So benzylic carbon is very reactive and very stable. So benzylic carbocation आपको बनाना है. So you have to prepare the benzylic carbon. So you will break this bond. Okay, this bond will break. So this bond will break and this iodine will get attached to the carbon. Iodine is a nucleophile over here. So this nucleophile will attack the benzylic carbocation. Right. So here carbocation will be formed. And this nucleophile iodine minus will get attached to this carbon. Plus the remaining group. This remaining group will form the alcohol. So 1, 2, 3 carbon chain. And on the second carbon, there is a OH. So that is your product. Okay, in the second one, yes, Ali will explain the second answer. Explain the second answer, which bond you will break and what will be the product. Yes, Ali?
Yes, ma'am.
Yes, explain the second answer.
Iodine gets attached to phenol and CH2.
Okay, this phenol and CH2 means this bond will break. So phenol,
Ma'am.
CH2 and iodine. And this remaining group will form the PHOH, means your phenol. Okay, so basically you have to break this bond. This is the same. And hydrogen will get attached over here. So you will get a phenol plus your this one, right? Okay, so benzylic halide is formed as a reaction occurs via SN1. Okay, and SN1 reaction, you know very well, it occurs via two-step. Okay, it follows two-step mechanism. In the first step, there will be a formation of carbocation, and in the second step, the attack of nucleophile. Okay, and the benzylic carbocation is very, very stable, right? So that's why you are just breaking this bond, right? This bond, and you are just forming the carbocation, benzylic carbocation, because it is very stable and it is very reactive, right? So that's why we just break this bond and we just form the benzylic carbocation. Okay, the next one is your diaryl ethers. Diaryl ethers. Okay, so who will explain me that this is a diaryl ether, right? Uh, this is the ether linkage, oxygen linkage, and both the side aryl group is attached. Benzene ring it is attached. So it is known as a diaryl ether. Okay, so diaryl ether does not give this reaction. Why? What is the reason why diaryl ethers don't give this reaction? When it is treated with any halogen acid, so there will be no reaction. Why? Just think about it and just tell me the answer.
And because no bond can break.
Yeah, why no bond will break, Ali?
Because of partial double bond character.
Yes, very good. Right, so you can see this oxygen is attached to the benzene ring directly, right? So the lone pair of this oxygen, okay, is involved in the resonance with both the benzene rings. So there will be a partial double bond character between this carbon and oxygen and this carbon and oxygen also, right? Which is very difficult to break, right? So diaryl ethers, why don't give this reaction? They don't show this reaction, okay, with HX, your halogen acid, because both carbon and oxygen bonds has partial double bond character due to the resonance and which is very difficult to break, right? So you can write down this reason in your exam. Next is your electrophilic aromatic substitution of anisole. Now, Rimda, tell me what is anisole? What is the structure of anisole? What is anisole? Yes, Ali, do you know what is anisole?
Phenol with CH3.
Not phenol with, you will, if you say phenol with, so phenol means this. Phenol means this. Phenol with CH3, it's not correct. Benzene with CH3, right? So benzene, this is a benzene ring with CH3. Not CH3, this is a toluene. If you say this, Ali, benzene with toluene, CH3, so it is toluene. It is not anisole. Okay, so OCH3, methoxy group. Okay, benzene with methoxy group, alkoxy group. So that is your anisole. Okay, see the structure of anisole. So anisole is this benzene ring with OCH3 group. Okay, this is your anisole. Now this anisole, this is structure of anisole, this OCH3 group is plus R group. Okay, plus R group, basically it is electron donating group. This oxygen has a lone pair. So it donates its electron to the benzene ring. Right? So this alkoxy group is basically a activating group. It is an electron donating group. It's a electron donating group. It donates its electron to the benzene ring, right? And due to that, it shows the plus R effect. It shows the plus resonating effect. Okay, plus resonating effect. And due to that, okay, due to the resonance, there will be a increase in electron density at ortho as well as at para position. When the electron donating group is attached to the benzene ring, what happens? It donates its electron, okay, and this electron basically the electron density, due to that the electron density increases at ortho or either para position. So in this case, when you take the any group, okay, any electron donating group is attached to the benzene ring. So in that case, the product will be ortho and para product, right? Whether you are just doing the electrophilic, aromatic, nucleophilic substitution, anything, so the product will be your ortho and para direct. Means the nucleophile or electrophile will get attached to the ortho or para position, right? So you will get a ortho and para product. So electrophilic aromatic substitution of anisole. So what is electrophilic aromatic substitution? Let's understand this. Electrophilic, electron plus filling, electron loving group. What is electrophilic? Electrophile means electron loving. Philic means love, right? Loving. So the groups or the you can say the groups or the compounds, okay, the especially basically which love electron. Okay, they are electron loving means they are electron deficient. Which group will love electron? Which don't have a much electron in it, right? Which is electron deficient, which lacks electron. So electrophiles are electron deficient, right? And on the other hand, nucleophiles are electron rich. Okay, that's why they have minus charge over it. They are anions, but the electrophiles are electron loving and they are electron deficient. So that's why they are cations. Cations means they when it has a plus charge, so plus charge means just opposite. It means it has a deficient of electron. It has a deficient of electron. It is electron deficient. So that's why it is cation. So electrophiles को हम कैसे show करते हैं? E plus. And on the other hand, nucleophiles को कैसे show करते हैं? Nu minus, because it is a electron rich, right? Electron rich. Okay, so electrophiles are electron loving, electron deficient. Now, so let's see the electrophilic aromatic substitution of anisole. So alkoxy group is an activating group. Okay, it activates the benzene ring. Due to the presence of activating group, electron donating group, it increases the electron density of benzene ring at ortho and para position, which leads to the formation of ortho and para product. Okay, so always remember, in the electrophilic aromatic substitution of anisole or any group, okay, any group which is attached to the benzene ring, which is electron donating. Okay, so you will get a ortho and para product because the electron density increases at ortho and para position, and due to that, the electrophiles come and attack that electron. That yeah, see this. This is your anisole. So one by one, we will see the different reaction, different electrophilic aromatic substitution reaction, right? So first is when you do the halogenation. When you do the halogenation, right? So halogenation में you can also use Cl2, that is your chlorination आप कर सकते हो. Your this here I'm just using the bromine, so this process is known as bromination, right? So anisole, when it undergoes bromination, right, which is a halogenation. So here, what is electrophile? Electrophile is Br plus. What is electrophiles? First, we have to analyze which is electrophile over here. So electrophile is Br plus. So this Br plus will get attached to the ortho and para position. So you will get a ortho plus your para position. OCH3 as it is. So first, this bromine will get attached to the ortho position, right? Plus your para bromo anisole. OCH3. And what is the para position? This is your para position. So this bromine will get attached. So it will give you ortho bromo anisole plus your para bromo anisole. Getting my point? Yes or no?
Yes, ma'am.
Okay, so write down. This is your ortho bromo anisole and this is your para bromo anisole. Now, second reaction is when anisole undergo nitration. So nitration may we use this combination concentrated HNO3 nitric acid plus concentrated sulfuric acid. Whenever you have to do the nitration, just use this combo. Okay, concentrated HNO3 plus concentrated H2SO4. Both should be in concentrated form. So this is your nitration. So in the nitration, what is the electrophile? NO2 plus. What is electrophile? NO2 plus. So this NO2 plus will get attached to the ortho and para position. So you will get ortho nitroanisole plus your para nitroanisole. Para nitroanisole. Third is your Friedel-Crafts alkylation. What is Friedel-Crafts alkylation? So when you add CH3Cl, okay, your methyl chloride in the presence of anhydrous AlCl. Okay, so this is a Friedel-Crafts alkylation. Okay, alkyl group. So here, this in the Friedel-Crafts alkylation reaction, the electrophile is CH3 plus. Okay, this methyl. Okay, the electrophile is CH3 plus. So this electrophile will get attached to the ortho and para position. So it will give you anisole, you will write CH3, right? And on the ortho position, you will write CH3. Similarly, you will get a paramethyl anisole, right? So this is these two are the products of the Friedel-Crafts alkylation of anisole. Okay, similarly, do the Friedel-Crafts acetylation. Okay, there are two types of Friedel-Crafts reaction. Alkylation, in which you will use alkyl chloride, CH3Cl. Okay, and the second one is your acetylation. So you will use acetyl chloride. What is acetyl chloride? CH3COCl. CH3COCl you will use. Okay, and this will be fixed anhydrous AlCl3 plus anhydrous AlCl3. So what is yeah, see Friedel-Crafts acetylation. What is the electrophile? So electrophile is your CH3CO. What is this? CH3CO is your electrophile. CH3CO positive. This is your electrophile. So it will attack OCH3, anisole as it is, you will write, and you will write CH3, CO. Okay, and this will attach over here from this carbon, which has a positive sign. Okay, so that's why I've attached this CO to this carbon, benzylic carbon. Okay, then it will give you a anisole, and this acetyl group CH3CO will get attached to the para position. One, you will write like this, right? So these two are the products. Halogenation, nitration, Friedel alkylation, and acetylation. Okay. Okay, now the question is, can anisole undergo sulfonation reaction? Okay, see. So whether it's undergo sulfonation or not, let's check it out. So if you do the sulfonation reaction, so in sulfonation, we use a concentrated H2SO4 only. Okay, concentrated H2SO4. So this concentrated H2SO4 will give you a H plus ion, only the H plus ion. So this H plus ion, right, due to the presence of H plus ion, this oxygen gets protonated. This oxygen, the lone pair of this oxygen will abstract this hydrogen, H plus ion, and here it will basically, यहाँ पे oxygen, this OH, it will become OH and the CH3. So when you do the sulfonation, when you try to do the sulfonation of anisole, so sulfonation does not basically anisole does not undergo sulfonation. Why? Because in the presence of H plus ion, means only the concentrated H2SO4 you are using. So it will give you the electrophile H plus. Okay, the electrophile here is H plus. So due to the presence of H plus ion, only the proton, the oxygen, the ethereal oxygen, this ether oxygen gets protonated. And due to this, the benzene ring will deactivate, right? Because इसका काम क्या था? This OCH3, this oxygen का क्या काम था? This OCH3 group में toxic group का क्या काम था? It just activate the benzene ring. But here what happens, this oxygen, okay, it oxygen because it's an electron donating group. So it does not, when in the presence of concentrated H2SO4, it gets protonated, right? It gets protonated, it abstracts the hydrogen from this, right? And it just deactivate the benzene ring. Okay, it just deactivates the benzene ring. Due to the deactivation of the benzene ring, the electrophile, okay, here will not attack. Basically, electrophile is H plus. So electrophile will not attack this benzene ring. It will attack this oxygen instead. Okay, and that's why anisole does not undergo sulfonation. Why it does not go under sulfonation? Because in the presence of concentrated H2SO4, the ethereal oxygen gets protonated and the benzene ring gets deactivated. Okay, and in your exam, if they ask you this question, so you can write this reaction also. By the help of this reaction, you can show. Okay, so anisole undergoes bromination in the absence of FABr3 catalyst because methoxy group is highly activating via plus M effect, plus mesomeric effect. Okay, or you can also write plus resonating effect, or resonance effect. Okay. Is this clear, Ali?
Ma'am.
Okay, so I have checked your homework as well as your answer sheet of the test. And I analyze that you always write in the, when I ask the mechanism, write on the mechanism, you just write on the mechanism point wise. You don't give the reaction, proper reaction. Please please proper write on the reaction. Okay? No need to write on the points. I just theoretical आपको नहीं लिखना है, right? It's a chemistry. It's a science, right? So in chemistry, you have to know, you have to write on the reactions. You have to show the reaction. Okay, just like that. Suppose if I give you to write on the mechanism, okay, so you will write down like this. Okay, no need to write on the point wise and just like a storytelling. Okay, you just show the reaction like this. So what's going on? Step 1, step 2, step 3. First step, there is a protonation. Okay, so try to show it using the reaction. Proper reaction mechanism you have to. Okay, from the next time, do it. Okay, next is your some commercially important alcohols. Some commercially important alcohol. First one is your methanol. First is your methanol. Okay, so in your syllabus, there are two important alcohols, methanol and ethanol. Okay, so first, write down methanol. Okay, so methanol is also known as wood spirit. Do you know why it is known as wood spirit, Ali?
Ma'am.
Okay, so because in the ancient times, this methanol has been prepared by a wood, right? By a destructive distillation process, right? So it was basically historically produced by a byproduct of the destructive distillation of wood. That's why it's being called as wood spirit. Methanol is also known as wood spirit. Now, the preparation, let's say the preparation. So we can prepare the methanol by a Bosch process. Okay, that process which is known as Bosch process. Now, what is Bosch process? So when methanol undergoes basically carbon monoxide plus H2. When you combine the carbon monoxide and H2, okay, and you do the catalytic hydrogenation. In the presence of a catalyst, the carbon monoxide undergoes hydrogenation, okay, at high pressure and temperature. In which catalyst? Zinc oxide and chromic oxide, your chromium oxide, Cr2O3. So this is known as Bosch process. What is Bosch process? So methanol is produced by a catalytic hydrogenation. Hydrogenation means the addition of hydrogen, right, in the presence of a catalyst. So this is known as catalytic hydrogenation. Catalytic hydrogenation of carbon monoxide, CO, okay, at high pressure and temperature in the presence of zinc oxide and chromium oxide, your chromium oxide, Cr2O7, O3, this mixture. So you just use the catalyst, this catalyst, zinc oxide and chromium oxide at this temperature, 200 to 300 atmospheric pressure and 575 to 600, this range of temperature. So this carbon monoxide will undergo a hydrogenation. There will be addition of hydrogen and you will get a corresponding methanol, CH3OH, right? So means the number of carbon will be same. You are using carbon, right? Carbon monoxide. So here only one carbon is there. So you will write CH3OH. Basically, you have to add four hydrogen, three to this carbon and one to this oxygen, right? So you will get CH3OH methanol. So this is known as Bosch process. Is this clear, Ali?
Yes, ma'am.
Now let's see the uses of methanol. Now, methanol are used as a solvent for paints. In the industry, we use the methanol as a solvent. Varnishes. Do you know what is varnish?
Ma'am.
Okay, so varnish is just a clear liquid that you paint onto the hard surface, just like a polishing जब आप करते हो, okay, just wood को जब आप polish करते हो, just from the clear liquid, so that is known as varnish. So in the varnish, this methanol is used. In the varnish, we use the methanol, okay, and this varnish is basically a clear, transparent liquid that you paint on the wood, okay, just to make them shine, okay, and just to protect them, right? So that is your varnish. And celluloids. Celluloids, do you know celluloids?
No, ma'am.
Okay, you have not heard this word earlier.
No, ma'am.
Okay, so it is just a plastic material, okay, that transparent plastic material which is flammable, which is used in the earlier times in the making of film. Okay, film जो reels होती हैं उसे बनाने में help किया जाता था, उससे वो बनाया जाता था this celluloids. So that is your celluloids, a thin transparent, okay, material, plastic material which is very flammable. But nowadays we don't use this celluloids. Okay, so we have many alternatives for that because this is very flammable. So that's why we don't use this. Now, instead of methanol, we use this acetone over here for this hydroxides. So this is the first use, solvent for pens, varnishes, and celluloids. Second use is in chemical industry, we use it for the manufacturing of formaldehyde. Okay. Now, can you tell me the formula of formaldehyde, Ali?
HCHO.
Yes, very good. HCHO, right? So in chemical industry, we use this methanol as a starting material to manufacture this formaldehyde. And also it is used as a denaturant. Denaturant is basically when you add methanol to ethanol. आप क्या करते हो? In ethanol, we just add some methanol to denature ethanol. Okay, to denature ethanol to make it unfit for drinking. Denatured alcohol क्या होता है? Denatured alcohol are those alcohol which is unfit for drinking. And methanol is denatured alcohol. And ethanol is basically, it is not a denatured alcohol. So to make the denatured ethanol, we just add, little amount of methanol to the ethanol to make it unfit for drinking and for the different purpose. Other than the drinking purpose, we just use this denatured alcohol. Methylated spirit may use करता. In the methylated spirit, we just use this denatured ethanol. Okay, and to make the alcohol unfit for drinking, we use methanol. Okay, to add to the ethanol. Okay, what we are supposed to do? Methanol, we just take the little amount of methanol and add it to the ethanol. Okay, why? To make the ethanol denatured. Okay, so it helps in the making ethanol as a denatured ethanol. Last is used to make other chemicals and drugs. Okay, it is also used to make other chemicals and drugs. So 1 to 2 or 2 to 3 uses are more than enough. If they ask you, write down the 2 uses or 2 applications of ethanol, so you can know, you can write down. Second is your ethanol. What is the other name of ethanol? Ethyl alcohol. Ethyl alcohol is the other name of ethanol. Now let's see the preparation method. So how we can prepare the ethanol. So commercially, ethanol is prepared by the fermentation of sugar. Fermentation, when you do the fermentation of sugar, right, which is present in the molasses. Molasses is just a thick brown color sugar syrup, right? Sugar cane से जो हम obtain करते हैं, that is a molasses. So we can ferment that molasses, sugar cane, or fruits like grapes to obtain the ethanol, right? So, and this is the method of preparation. Suppose we just take the sucrose, okay? We just take the sucrose and we just add water to it. And in the presence of invertase enzyme, so invertase enzymes is basically, what is the role of this enzyme? It breaks the complex. Okay, this sucrose is a complex sugar, right? So this invertase, in the presence of this enzyme, it breaks down. Okay, the sucrose breaks down to form a glucose plus fructose. Okay, and glucose plus fructose, both formula is same, C6H12O6, C6H12O6, glucose and fructose, right? So first step, when sucrose, okay, when it is reacted to water, water is added to the sucrose in the presence of invertase enzyme, right? So it will, sorry, sucrose will decompose or break down to form a glucose plus fructose. Okay, now second step क्या होता है? When you take the either glucose or fructose, and when you add the zymase enzyme, so zymase enzyme क्या करता है? It just remove the carbon dioxide from that. Okay, it just remove the carbon dioxide from that. So carbon dioxide gas will be liberate out. Okay, and here the fermentation will occur and you will get a ethanol. C6H12O6 in the presence of zymase enzyme, it will give you 2 moles of C2H5OH. And what is this? C2H5 is your ethyl alcohol, ethanol. Plus carbon dioxide gas will be liberated. And yeah, one more thing, this fermentation process takes place in anaerobic condition. Okay, means in the absence of oxygen. It occurs in the absence of oxygen. Now the question is, if you do this fermentation process in the aerobic condition. So what we are supposed to do? So which product will be formed? So instead of, basically what happens, this when like little bit oxygen रह जाता है, right? Little bit oxygen. So due to the presence of oxygen, right? So this ethanol will oxidize to the ethanoic acid. This alcohol, okay, this primary alcohol, in the presence of oxygen, right, it will oxidize to a corresponding ethanoic acid. So that's why, and due to the formation of ethanoic acid, the taste of the ethanol, the taste of this alcoholic drink will become worse. Okay, the taste will be very destroyed. So that's why we do the fermentation process in the anaerobic condition, right? So here carbon dioxide is released during the fermentation process, and if air gets into fermentation, what happens? The oxygen of the air oxidizes to ethanol to ethanoic acid. And due to the formation of ethanoic acid, it destroys the taste of alcoholic drink. Right. So that's why that is the reason why we just do the fermentation in the anaerobic condition. Clear, Ellie?
Ma'am.
Okay. Next is your uses. Uses of ethanol or ethyl alcohol. So first is it is used as a solvent in paint industry and in wine making industry. Right, so we just use a ethanol in the solvent. Again, we can use the methanol as well as the ethanol as a solvent in paint industry, and in the wine industry we use this ethanol. Second is we use this ethanol in motor fuel additive. Okay, motor fuel additive, which is also known as power alcohol. Okay, so basically, this motor fuel additive may we just use the ethanol as a power alcohol. So ethanol first, when ethanol is added to gasoline, right? So gasoline basically is known as the power alcohol. Okay, when ethanol plus gasoline, when gasoline is added to the ethanol, so it is known as power alcohol, which is used in the engine to improve the performance of the engine and to reduce the pollution. Right. So why we use this ethanol in a power as a power alcohol? Okay, so it is used as an additive. Okay, in the motor fuel, basically to improve the engine performance and to reduce the pollution. Right, so it basically increases the fuels की rating को increase कर देता है, which helps prevent the engine, okay, and basically is smooth. Okay, it basically make the engine very smooth, and powerful combustion will takes place over there. So that's why we use this as a motor fuel additive. Okay, as a power alcohol, we can say that. So ethanol plus gasoline, आपको याद रखना है, ethanol plus gasoline is known as your power alcohol. And what is the role? What is the application of this power alcohol? Okay, so it is used in the engine, okay, basically to improve the engine performance and to reduce the pollution. Clear, Ali?
Yes, ma'am.
Okay, next is it is a starting material for producing different compounds, other compounds also like ether, your acetic acid, and iodoform. We can prepare these other compounds, okay, from the ethanol also. It is a starting material for the other compounds preparation. Ether, acetic acid, iodoform, etc. Again, you know very well this, okay, as we use this in day-to-day life, used as a antiseptic reagent, okay, in hand sanitizers, the ethanol we use in medicines, okay, in homeopathic medicine, we use the ethanol as well, right? So these are some uses of ethanol, okay, its preparative method. So these two are the commercial important alcohols. Okay, आपको ये याद रखना है, is preparation and uses. Preparation and uses are important. Okay, now see the last topic is distinction between primary, secondary, and tertiary alcohol. how we can distinct between the primary, secondary, and tertiary alcohol. So we have a test. Okay, first test is your Lucas test. Lucas test basically we do it for the primary to distinct between the primary, secondary, and tertiary alcohol, right? And what is Lucas reagent? So Lucas reagent is the anhydrous ZnCl2 plus HCl. This combination, this combo is known as Lucas reagent. Anhydrous ZnCl2 plus HCl, right? So Lucas reagent is used for the distinction of primary, secondary, and tertiary alcohol. What is Lucas reagent? Lucas reagent is used for the distinction between the primary, secondary, and tertiary alcohol. Right. So, and basic general reaction is this. Okay, this is alcohol. Okay, ROH, general alcohol हमने ले लिया. When you add the Lucas reagent, means anhydrous ZnCl2 plus HCl. So here, the reaction will takes place and it will give you a white color precipitate, a white color product, which is known as RCl. Right? Your halogen chloride, your chloroalkane, you can say chloroalkane. You will get plus water. Okay, so water you will get, and in the water there will be a PPT, white color PPT, which is your RCl. Okay, so this is the general reaction. Now suppose if you are doing this experiment in your lab, right? Your teacher gave you three unknown compounds. Okay, three unknown compounds, and she asked you to distinguish between these three compounds. Okay, she only told you that it's a alcohol. Now you have to check it out whether it's a primary, secondary, or tertiary. Now how you will check? So you will do this test. One by one, you will take primary, okay? You will take the unknown compound. Suppose you take the unknown compound, okay, in your test tube. Now add zinc anhydrous ZnCl2 plus HCl. This Lucas reagent, when you add this, okay. So if you will see no turbidity at room temperature, you are doing this experiment, right? At room temperature, if there is no turbidity, no white appearance in your test tube, so it is your primary alcohol. It is your primary alcohol, right? But if you give some temperature, at the room temperature, there will be no reaction in the primary alcohol. But at room temperature, at certain temperature, when you increase the temperature, आप उसे अगर heat कर रहे हो, so that turbidity will come. Okay, after some time, the turbidity will come, and that confirms that your alcohol is a primary alcohol. So what does this mean? Primary alcohol on treatment with Lucas reagents, there will be no reaction at room temperature, but there will be a reaction when you give some heat. When you increase the temperature, then turbidity will come. So that is your primary alcohol. Okay, suppose another compound you will take. Okay, just add the Lucas reagent and turbidity at the room temperature. Again, you are just doing the experiment. So turbidity, you will get the turbidity after 5 to 10 minutes. When you just analyze, just observe the test tube, okay, observe the reaction, and you analyze that the after 5 to 10 minutes, the turbidity is coming up. Okay, the white appearance आप देख रहे हो. It means the RCl is being formed. Okay, RCl बन गया है, and that is the white PPT over here. So it confirms that your alcohol is secondary alcohol. So when secondary alcohol is on treatment with Lucas reagent, it will give you a turbidity, but after some time, after 5 to 10 minutes, you will see the turbidity. So it confirms that your alcohol is secondary alcohol. Getting my point, Ali?
Yes, ma'am.
Similarly, tertiary alcohol on treatment with Lucas reagent, there will be a turbidity immediately. Immediately, the turbidity will occur. Now, why this is so? Because you know very well, tertiary alcohol is more reactive than your secondary one, than your primary one. So that is the reason. Tertiary alcohol is more reactive. Why? Due to the formation of your tertiary carbocation is more reactive and very stable. So that's why when you add the Lucas reagent, so immediately the turbidity comes. Immediately the reaction happens and the turbidity comes. Right. After that, secondary, it will take like 5 to 10 minutes for the reaction to proceed. And the primary one, at the room temperature, it will not show the reaction. It will not give the Lucas test. It will give the negative Lucas test. But if you provide some heat, external temperature provide कर रहे हो आप, so then only the reaction will occur and you will get a LBD. So that's how you can distinct between the primary, secondary, and tertiary alcohol by the Lucas test. Now the question is, which type of question can come in from this topic, right? Lucas test. Suppose they will give you like propane 1-ol. How you will distinct between the propane 1-ol and your 2-methyl, 2-methyl, 2 propane 2-ol, 2-methyl propane 2-ol. 2-ol. Okay, so this is a propane 1-ol, CH3, CH2, CH2OH. And what is this? Propane 2-ol, CH3. Okay, on the second position, there is a OH group, and on the second position, there is a. What is this? This is a tertiary structure. This is your tertiary one. This is your tertiary alcohol, and this is your primary alcohol. How you will distinct between these two? So you can distinguish between the propane 1-ol and 2-methyl propane 2-ol by a Lucas test, right? So this primary alcohol, this propane 1-ol will not give the Lucas test, okay? When you react, when you treat this, when you add the Lucas reagent, so there will be no reaction at room temperature, right? And this is a tertiary one, so immediately there will be a turbidity. You will see the turbidity immediately. So this will give the Lucas test. So that's how you will distinguish between by the Lucas test, right? So this type of question can come from this topic. Kelly,
Yes, ma'am.
second test is your iodoform test. Iodoform test. Now in the iodoform test, we just take the reagent. So the reagent I2 plus NaOH. Okay, alkali आप लेते हो, strong alkali, sodium hydroxide with I2, iodine. So iodoform test is that test which is given by all alcohols which contains CH3, CHOH group, right? So your alkyl group, the alkyl group should be attached to OH, and OH should attach to one CH group and one CH3 group, right? So what I said, OH group will should get attached to CH, means at least one hydrogen होना चाहिए इसके पास, but if it has two hydrogens, so it's okay. At least one hydrogen should be. So OH is attached to this group, CH2 group, and this CH2 group should be attached to one CH3 group, right? This is the necessary group. This is the conditions for this reaction. For the iodoform reaction, okay, for the iodoform reaction, this group should be present only. Okay, so all alcohols which contains this group CH3 CHOH group, okay, linked to the carbon or hydrogen atom can be distinguished from the other alcohols by the iodoform test. Okay, it's very simple. Suppose we have this CH3 CH2OH, right? So what is this? This is your ethanol. So when you add I2, iodine plus NaOH. Okay, iodine plus NaOH, and you give some heat. So you will get CHI3, iodoform. It will form a pale yellow color PPT will be formed. Pale yellow color PPT, which is known as iodoform, CHI3, right? Plus you will get a salt, okay? See your HCOO Na minus salt and 5 NaI. Okay, so basically this reaction, basically how you will distinguish between, so basically the pale yellow color PPT will be formed. If pale yellow color PPT आपको मिल रहा है, so it means the reaction has already happened and the iodoform test is positive. It means that this alcohol contains this group, CH3CHOH group. Why? This alcohol contains this group. So it confirms the iodoform test. Iodoform test is positive, right? So when the pale yellow color substance is formed. So here you can check. This is CH3, CH3, CH2OH, right? So OH is attached to CH2 and CH2 is attached to one methyl group CH3. Okay, so this group is present. So that's why it gives this test. It gives this iodoform test. But if you take the methanol, okay, if CH3OH, methanol plus I2, when you add the iodoform reagent, okay, I2 plus sodium hydroxide, and you give further heat, so there will be no reaction. Why there will be no reaction? Because here you can see OH is directly attached to CH3, right? So this group is not present. Okay, this CH group is not present. So that's why this methanol will not give this test. So there will be no reaction. So this group should be there, CH3, CH and OH. OH should be first attached to CH. At least one hydrogen should be there to this carbon, and after that it will be attached to CH3. So that this is condition. This is the condition for the iodoform test. So phenols, and yeah, one more thing, phenols and alcohols can be distinguished using this test. You can also distinguish between the phenol and alcohols by using this test, right? Any group which contains this COH and this CH2 and the CH3 group, this group, okay, will give the iodoform test. So phenols and alcohols ko bhi you can distinguish between these two using this test, iodoform test. And iodoform test is positive only for the primary alcohol, especially for the ethanol, right? So iodoform test is positive only for the primary alcohol and it is especially for the ethanol. But some secondary alcohols also give this reaction, iodoform reaction. If the secondary alcohol possesses a methyl group directly attached to the carbon atom bearing the OH. Okay, so if secondary alcohol OH है, suppose we have any R group, just a second. Suppose we have CH2, CH3 group, and here any CH group and OH group is attached, then CH3. Okay, so just analyze this alcohol, whether it will give the test or iodoform test or not. So yes, it will give. So what is this? This is a secondary alcohol, right? Secondary alcohol. So secondary alcohol, if it possesses OH is attached to CH group and this CH is attached to CH3 group. So if this group is present, then only the secondary alcohol will give this iodoform test. Clear, Ali?
Yes, ma'am.
So you have to check this group, that this group is present or not. Okay, so some secondary alcohol that possess a methyl group directly attached to the carbon atom bearing OH group. Okay, so this also gave the iodoform test. Now, tertiary alcohols do not give a positive iodoform test. Why? Because they lack. Suppose this is a tertiary alcohol. Right, it will not give the test positive iodoform test because this OH group is attached to this carbon and this carbon has no hydrogen. It has no alpha hydrogen, right? You can see it has no alpha hydrogen. So the conditions था जो group present होना चाहिए, it is not present. OH should attach to CH. At least one hydrogen should be attached, should be present, one alpha hydrogen. But there is no alpha hydrogen. So that's why tertiary alcohols do not give a positive iodoform test. So you can distinguish between the primary, secondary, or tertiary alcohols. Suppose if this tertiary alcohol is given, right? And the other is this one. So how you will distinguish between these two? By the iodoform test. Right, so this will give the iodoform test, but this will not give the iodoform test. Right, so that's how you can distinguish between these. Okay, the last one. Now let's do some questions. And after this, we will complete this chapter. Okay. So first question is, give a chemical test to distinguish between pentane 2-ol and pentane 3-ol. Pentane 2-ol and pentane 3-ol. So let's see. Pentane 2-ol. So how we can do the iodoform test. So when you add I2 and NaOH, so when you do the iodoform test, okay, so this is pentane, pentane 2-ol, 1, 2, 3, 4, 5, and this is on the second position, there is a ol. And this is pentane 3-ol, pentane 2-ol and pentane 3-ol. Now let's check it. So when you add I2 plus sodium hydroxide, so because आपको क्या check करना है, the necessary group. It is the condition OH. For the iodoform reaction, this group should be present. OH should be attached to CH and there will be one methyl group. So this group is present, it means it will give you the iodoform test, positive iodoform test, and it will form the yellow color PPT, which is your iodoform, CHI3 plus one carbon. Okay, this carbon basically it will form the CHI3 and CH3, CH2, CH2, and it will get oxidized to a corresponding your sodium salt. It will form a sodium salt. 1, 2, 3, 4, 5, 4 carbon will form the sodium salt and 1 carbon will form the yellow color PPT, which is iodoform, right? Plus sodium iodide. This is the product. Means the propane 2-ol will give the positive iodoform test. But your propane 3-ol, you can see OH is attached to CH group and CH is attached to CH2 group. One, there should be 3 hydrogens, CH3 group होना चाहिए, right? So, but it lacks that, it lacks this, right? So, this propane 3-ol lacks this group, see OH, CH2 and CH3. CH आप लिख सकते हैं, at least one carbon. This group lacks for it. Because here, after CH, okay, there are both the sides CH2 and CH2 group is attached. And the compulsory क्या होना चाहिए? CH3. It should be CH3. So that's why propane, your pentane 3-ol will not give the test, will not give the iodoform reaction. Means there will be no reaction and it will show the negative iodoform test and it will show the positive iodoform test. So that's how you can distinguish between these two. Second question was benzoic acid and phenol. Yeah. So there's one more reaction. Okay. Yes, Ali, do you have any doubt?
Ma'am, in pentane 2-ol and pentane 3-ol, we can distinguish with Lucas test also, right?
Yes, Lucas test. Yes, you can do the Lucas test also. Why you can do the Lucas? See, both are secondary alcohol. So how you will distinguish between these two, Ali? Lucas test is for the primary, secondary, or tertiary, right? And both are secondary. You can see OH is attached to this carbon, and this carbon is further attached to two groups. It means this is the secondary alcohol. Again, this OH is attached to this carbon, and this carbon is further attached to two groups. It means again it is a secondary alcohol. Both the alcohols are secondary, so how you can distinguish between these two by Lucas test? Yes, so you can distinguish between these two by iodoform test. Okay, Ali?
Yes, ma'am.
Okay, now see the next question. Benzoic acid and phenol. How you will distinguish between the benzoic acid and phenol? So there is one more test. Okay, let me explain this. There is a test which is known as ferric chloride test. Okay, so let's see what is ferric chloride test. Ferric chloride test is basically a test which is used to distinguish between a benzoic acid and phenol, right? Benzoic acid and phenol. So this test basically, let me explain this. Just a second, yeah. So ferric chloride test जो होता है, it is used to detect the presence of phenol. It is used to detect the presence of phenols and other compounds, with hydroxyl group, with OH group attached to the aromatic ring, okay, such as your enol हो गया, आपका oximes हो गया, your sulfonic acids like this. So this FeCl3 test is to detect for the presence of phenol or its derivatives. Phenols or its derivatives. So we can distinguish between the benzoic acid and phenol by using this test. Okay, because both are, this is phenol, okay, and this is your benzoic acid, COOH. Okay, only the difference is OH group over here and here COOH group, COOH group, carboxylic acid group, right? So what is the difference between these two? Let's check it using the reaction, right? So here is a ferric chloride test. So in the ferric chloride test, we use a ferric chloride, FeCl3. When you take the phenol, C6H5OH, when you add the ferric chloride, so you will get a violet color complex. So this iron in the ferric chloride, it get combined, ये इसके साथ एक complex बना लेता है. C6H5OH के साथ ये complex बना लेता है, which is violet color. Plus HCl gas will be liberate out. HCl gas will be liberate out. So this color, this complex will be in PPT form. So you will get a violet color PPT. When phenol, okay, when you do the ferric chloride test of phenol, so when phenol is treated with FeCl3, okay, ferric chloride, so you will get a violet color PPT, okay, which confirms that it is a phenol, okay, which confirms that it is a phenol. But the same thing, the same reaction, ferric chloride test, if you do for the benzoic acid, if you take the benzoic acid and if you add the ferric chloride test, ferric chloride over here, in that, so you will, this iron, again it will make a complex with the C6H5COO. Okay, C6H5COO. And it will be a buff color. The color of the PPT will change. Okay, the reaction is same. Ferric chloride test आप कर रहे हो, but in the case of phenol, you will get a violet color PPT. But in the case of your benzoic acid, you will get a buff color. Now, what is buff color? Buff color is just a pale yellowish brownish color. Pale, बिल्कुल pale सा yellowish brown color का होता है. That is a buff color. Right. So in the when benzoic acid is treated with FeCl3, so you will get a buff colored PPT. So that can differentiate between the phenol and benzoic acid. Right. So this test, how we can distinguish between the phenol and benzoic acid? By ferric chloride test. So when you add ferric chloride, okay, in the phenol, so there will be a violet color PPT. So violet color PPT, if you get, so it is a phenol. Okay. And if you add the ferric chloride, FeCl3 with benzoic acid, so you will get a buff colored PPT. So it confirms that your reactant, okay, or your unknown substance is your benzoic acid. Okay, so that's how you can distinguish between these two. Clear, Ali?
Yes, ma'am.
Okay. Okay, so first question, this question, I will give you some time. Just do this question. Which reagent you will use in the conversion of the following? First is your butane 2-on to butane 2-ol. Butane 2-on means ketone से आपको क्या form करना है? Alcohol. So which reagent you will use? It's very easy. First, analyze. In the conversion part, always write down the reaction first. Draw the structure butane 2-on.
Reducing agent,
Yes. So which reducing agent you will use?
LiAlH4.
LiAlH4. Yeah, you can use. Lithium aluminum hydride is a strong oxidize reducing agent, so you can use lithium aluminum hydride, and it's a carbonyl compound, right? Aldehyde and ketone. So aldehyde and ketone ke liye you can also use the sodium borohydride, right? NaBH4. You can do anything. You can add lithium aluminum hydride, sodium borohydride. You can use the catalytic hydrogenation, right? H2 in the presence of any catalyst, nickel, palladium, platinum, any catalyst, right? So it will reduce this ketone group to a butane 2-ol. Do the second. Second again is easy.
KMnO4.
Very good. So oxidation of primary alcohol to carboxylic acid. So you can use KMnO4. Okay, now do this conversion really quickly. Benzyl chloride to benzyl alcohol, and then methyl magnesium bromide to 2-methyl propane 2-ol.
Ma'am, in the first one, we will add KOH.
Yes, you can use KOH or sodium hydroxide, anything. Write on the proper reaction. Benzyl chloride. It's benzyl chloride. Right. So it means CH2 benzene ring with CH2Cl. This is your benzyl chloride. Plus, when you add KOH, potassium hydroxide, right? So there will be a substitution reaction. A plus and OH minus, right? So OH minus is your nucleophile over here, right? So it will attack this carbon, and from here, this chlorine will be removed. A plus and OH minus will attack this carbon, and from here, this chlorine will remove, and you will get CH2OH, your benzyl alcohol. Okay, second one, Ali. Methyl magnesium bromide, Grignard reagent. That's very easy. First, analyze this product. It's 2-methyl propane 2-ol. Means you are just getting the tertiary alcohol. Tertiary alcohol. Tertiary alcohol कब आप मिलता है आपको when you just react the Grignard reagent to a ketone. Okay, we have done 3 reactions. When formaldehyde is treated with the Grignard reagent, you will get a primary alcohol. Other aldehyde, other than the formaldehyde is treated with the Grignard reagent, you will get the secondary alcohol, right? And tertiary alcohol, your ketones with your Grignard reagent, it will give you a tertiary alcohol. Now your product is tertiary alcohol. So you are just taking the Grignard reagent, right? So just attach me 2-methyl propane. So you will take the propanone. Propane है ना, right? So propane से आप क्या लोगे? Propanone. So when you take CH3, CH3 plus add this methyl magnesium bromide, CH3 MgBr, right? So what you will get? So this CH3 will get the partial negative charge and this magnesium bromide will get the partial positive charge. So this CH3 will attack over here and this bond will shift over here. CH3 and you will write C. Oxygen negative charge and this CH3 as it is. So this CH3 get attached over here. This CH3 get attached over here and oxygen पे negative charge, so this MgBr will get attached. Right. In the next step, H plus and OH minus. Okay, acidic hydration करा दो. So this H plus will get attached to the oxygen and this OH minus will get attached to the MgBr. You will get CH3, C, CH3, CH3. You will get a this structure MgOHBr. Now what is this? This is your 2-methyl propane 2. That's the product. Clear, Ali?
Ma'am.
Yeah, so if you know the mechanism, it will be very easy for you